Okay, good morning. I'm definitely of the zombie morning type of person, so I hope it won't show too much. But it's a great opportunity, and thank you for the invitation to also try some new content for a talk that won't be exclusively about our own work. So who are we? We are Unfold. So as mentioned, we founded the studio in 2002. So that's me and my partner, Claire. The name is derived from the first project that Claire and I did collaboratively in 2002, in which we made three-dimensional scans of our body and used that data. We cut parts of that data, we unfolded it like a cardboard box into flat patterns, and then reconstructed that into kind of accessories that are low polygon approximations of our own body. It shows a little bit our interest in bridging the digital world and physical making. So if you look it up, unfold to unfold in the dictionary, it literally means to open or spread out from a folded position. But over the last years, that second meaning, a story that reveals itself gradually to the understanding, grew more important for us. Because all our work kind of stacks up together and tells a larger story. And it's a story about the designer. Who is the designer and what is our role in a new society? In a society that's increasingly post-industrial, that's digitally connected. And if you look at the history of the designer, like the grandfather or mother of the designer was the craftsman. It was a person that had the whole process of designing, producing, manufacturing, financing, all embodied into one person. And yet he or she had a deep knowledge of the whole process. And then came the Industrial Revolution, and the designer became kind of this small cog, a small wheel in a big machine. And a lot of responsibility and a lot of close contact with this whole process was being lost. And what we now see is that it's moving into something new. And most of our work is exploring just that. What is that role? What is design? We're probably mostly known for our work on ceramic 3D printing, a technique we developed in 2009. Throughout the talk, there will be a couple of examples of that interweaved. So if you look at our work, a lot of it involves 3D printing. Because it's kind of an ideal way to go from digital to physical. But we're not mainly interested in the technique. We're more interested in what kind of future implications this technique has on the way we manufacture and use things. Which brings me to the theme of my talk, the new ink disruption in the third dimension. So what exactly is the relation between the making of things and ink? If you look at the Industrial Revolution, the first Industrial Revolution brought us steam power. And with steam power, we could automate things, we could mechanize them. And a lot of hand-operated machines became automated, greatly increasing the output. So 200 years ago, this is the first steam-powered printing press, which was a mechanization of the Gutenberg press, which was invented like 350 years before that. And it made that all the ideas and the concepts and the developments of the Industrial Revolution could be spread super easily and super fast across the world. So something that might have been an evolution became a revolution because we had ink and we had machines to spread the idea. So this was the ink of the first Industrial Revolution. The second Industrial Revolution brought us electrification, and more importantly, the reorganization of labor and division of labor. This is the first assembly line at the Ford Motor Company, where people were not tasked anymore with building an entire car, but just a small section, making it incredibly efficient. And this efficiency gave birth to consumers, which we are today all. And mass production made things very cheap and often disposable. So here's ink again. Big made ink instead of a replaceable thing, a disposable thing. And today we hear stories, signs, and things about the third industrial revolution. Whether we're there, is it happening? We don't know yet. But it's about distributed communication systems such as the internet combined with social networking, collaboration, distributed renewable energy, and digital manufacturing. And the ink of the third industrial revolution is data. It is inherently digital. What is digital manufacturing? It's the infusion of this connected data into our manufacturing system. And probably the machine that speaks most to the imagination today is the 3D printer. But trust me, if we look at this again in 50 years, we will look at it as a very crude, very ineffective, very primitive way of making things digital. But it's a start. And I guess you've probably all heard about 3D printing, because in the last kind of 4 years, it took a huge, it went really uphill, and mainstream media covered it in a big way. Why is that? Because 3D printing is not at all new. It's invented mid-1980s, and it was actually known as rapid prototyping. And I've pulled up this Google Trends diagram to show where rapid manufacturing was replaced, but with the more colloquial term 3D printing. And why did that happen? Why did that happen around 2011? There's two enablers for this. One is this man, Adrian Boyer, a professor of mechanical engineering at the University of Bath, and he came up with the first open source 3D printer. So he developed a 3D printer starting in 2005 for which he put all the plans online, and you can download those plans and you can build one yourself. So a machine that was previously 100,000 euros and upwards was suddenly available for around 500 euros in parts, or 1,000, 2,000 euros if you want it pre-made. The second development was this company called Shapeways, and we have to give them credit because it's a Dutch company, they beat us Belgians. But iMaterialize is a similar company. And what they did is they took this industrial 3D printer from the 1980s and 90s and made it accessible to consumers. So previously with rapid manufacturing or rapid prototyping, sorry, it was used as a method to prototype parts for the industry. So it was a business-to-business technology. What did Shapeways? They opened it up, made a really easy accessible platform online, something like YouTube, where you can easily upload your digital files, get an instant quote in about a few dozen materials, and then get it printed and shipped to your door. And the second aspect is that it offers a platform for commercialization. So designers can put their digital content online and people can order them and get them printed on demand and shipped to their door. So these two developments lowered really the barriers into production for everybody. It's like having China on your desktop. But there's an important difference with traditional manufacturing, and I think it's very important to point that out for those who are not intimately familiar with 3D printing or digital manufacturing. And it's this. Traditional manufacturing relies on, it's subtractive, it relies on heavy machinery and a large upfront investment. This is injection molding of a plastic chair. You need a multiple 100,000 euro mold in order to start producing a chair. And this is one of the characteristics of the second industrial revolution, this huge, large-scale, expensive manufacturing system. So when we want to produce something, we have to make at least a few thousands, 100,000 of copies of a chair to get our investment, to get our return on investment and to earn our investment back. With 3D printing, the mold is digital. There is no mold. Once you have the machine, you can actually produce a single item. You can produce a single thing. So there's no more upfront material investment. So if we talk about making manufacturing accessible, it's of course not a scaling back of this manufacturing system. It's something that only digital manufacturing allows us to do. And When technology becomes accessible, it empowers people. Just like the internet gave people power, the power to communicate or overcome physical distance, and the power to share ideas. Digital fabrication methods, when connected with this internet, can convert this power into tangible objects. And I will show you 2 examples of what I mean with this empowerment. What does it mean when manufacturing becomes accessible? When everybody in this room can manufacture something. This is the RoboHand project started by Richard van As and Evan Owen. Richard van As is a carpenter from South Africa, and he lost a couple of the digits of his hand. When he saw online that Evan Owen, he was a designer that was playing with this mechanical hands, like a bit Edward Scissorhands like hands, and he built this aluminium robotic hand for himself, just to play around. And when Richard saw that, he saw a solution for his problem. He didn't have fingers, so what if he could build a mechanical hand? But he didn't have the skills. What's so powerful is that these 2 guys, each with a 3D printer, were able to develop a open source and super accessible prosthetic hand. So Evan would design the hand, send it by email to Richard, and Richard would print it out and test it. This kind of manufacturing process would traditionally, or development process would traditionally take literally years. But now it overcomes and bridges physical distances. And digital manufacturing, or everything that's digital, is in essence frictionless. So the Enable company or community that is the offspring of this project is currently, I think it is a collaboration of a few thousand people around the world that are designing, producing, and distributing prostheses to people that previously had no access to a very expensive technology. And you might wonder, isn't this like something only the West can afford? And no, this is a printer that's being built in Togo by Afate Gniku. And what he cleverly does is all the e-waste that we ship to Africa, he repurposes it and builds 3D printers with this. Of course, if you make technology accessible, if you make it easy to use and to spread something, you get a whole lot of issues. If you open manufacturing up for non-professional content, you get more IP or intellectual property infringement. And the inevitable question is 3D printing the next Napster? For those who remember, Napster was the first easy way to share music online and really brought the big disruption in the media and music industry. And I'll be showing 2 examples. This one is from Joaquin Baldwin from 2013. He's an animator, and he really likes this game called Final Fantasy. It's a game, I don't know from which time. Somebody played it? Final Fantasy. It's an old version. And what he did is he extracted figurines, the game characters, from the DVD, from his PlayStation DVD, and uploaded them to Shapeways to produce them in 3D printing. In essence, this is copyright infringement. You cannot copy something from a DVD. But he was not copying actual real-life content. The game company sells figurines, but they're super high-res. And this is something entirely different. Because what Joaquin was interested in, or was craving, was this low-polygon, kind of retro-looking game figurines. And the first thing the owner of the intellectual property did, they're called Square Enix, is sent a cease and desist letter to Shapeways asking them to remove these objects from their platform so that they couldn't be produced anymore. And this is the typical thing that companies do, right? If they see something that is theirs, they shut it down if it's not being used according to their standards. But this is the thing. What Joaquin did is basically fan art. He's the biggest fan of that game. He uploaded that just as a hobby, not to make a real profit. And suing one's customers is quite a crude and ineffective way to protect your business model. And I hope we have learned a lesson from the Nyan Cat. This is the number 5 most viewed YouTube video in 2011. And why is this the most viewed YouTube video on YouTube? Not because it's super high definition or it's super great content, but because digital content is super easy to remix and to share. And it's really effortless to appropriate digital content. And I think this remix culture is one of the most iconic new creative expressions that came out of our digital age. The way we can actually take something, make it our own, create a new layer and new personal meaning to it, and then share it instantly to our friends. A second example is a more positive way in which somebody who owned an ID or a property embraced this kind of remixing and fan art. This is the Strand based by Theo Janssens. Theo Janssens is a Dutch artist who creates these huge kinetic sculptures that walk on the beach. They're made by hand out of like electrical conduit pipes. And they're completely mechanical. So they're the size of this stage and they walk on the beach. Two design students approached Theo with the idea to create a 3D printed copy of his strand beasts, like a miniature version. And Theo was immediately drawn to the idea because he always envisioned his strand beasts as reproducing themselves and actually walking maybe to the Gamma or to the DIY store to steal their own pipes. But somebody else was doing the stealing, and I want to use stealing in a good way. So they developed, together, Theo and these two young designers developed a 3D printed strand beast. And what's interesting is that it's using a characteristic of 3D printing that means that you can produce things like a completely mechanical thing with hinges and moving parts in one go. You don't have to assemble it. You print it in one go, and like you see here, a little bit metaphorically, it walks out of the printer. So this is, I think, the new way in which we should deal with people remixing and appropriating content. In 2011, we did ourselves with our studio a little experiment to bring this issue to the forefront, because we noticed that a lot of the industry isn't really bothered by 3D printing and the possible implications, because the argument is always the quality of a 3D print is not enough. It will never compete with what Vitra or IKEA produces. And that might be true, but what this NIANCAD also showed is that we don't really care about quality. We don't really care about the material quality of something. Of course, a lot of people care, and I care about it, but it's not the most important factor. So we decided to make this mobile 3D copy shop. So it's a little bit like a New York hot dog stall in which we would scan 3D designs and appropriate them and sell them on the street. We did this in Milan, in the center of the design industry, the yearly Salone del Mobile, and started to copy and show a near future scenario of how people would appropriate and start to make design and physical objects their own. And we don't want to say with this that the end is near. That's not the message we want to give the design industry, that copying will kill everything. What we want to show is that, or trigger is that we think about new ways of dealing with this, about new scenarios of how digital manufacturing and the digital distribution of goods makes new possibilities. And this is a recent example by Hasbro, in which Hasbro is the largest franchise owner, I think, of toys and animation movies. So this is My Little Pony. And I don't know how many of you are like into the whole brony subculture thing. I hear one person laughing, but just look it up. Bronies are brothers, men that collect My Little Ponies. And it's a huge subculture. And My Little Pony, or Hasbro, kind of saw that cleverly. They cannot produce using traditional manufacturing. They cannot tailor to that kind of subculture because it's too niche. But what they did is they opened their intellectual property, their copyright, for individuals to use it and to create new content based on My Little Pony. And of course, the way it works is they allow individual makers and designers to upload new digital designs to Shapeways, who will then sell it and print it on demand for everybody who wants to buy one of these figurines. Of course, Hasbro acts as a gatekeeper, so there's no, there's nothing that is inappropriate. to say it mildly. So this is, I think, again, the new way of using and benefiting from digital distribution and manufacturing. Because it's digital, products that are designed for 3D printing are flexible, because you don't need to stock thousands of items in a warehouse. You don't need to manufacture 1 million identical copies. You only manufacture at the very last moment, and you can manufacture one for one person. That means that 99% of the lifetime of a product is digital. And that means that we should be designing products for digital instead of material. And this is one example. This is the kinematic system from Nervous System from last year. I think they also have a dress. But basically, it's a design system for jewelry. So you can go online and design your own necklace. You can customize it, the size, the aesthetics, the price point, of course. If it's larger and more complex, it will be more expensive colors, etc. And that means that a product becomes very flexible and that it becomes very personal when you start to interact with it. And you produce only one necklace that is exactly the one that you want. Another one that we did in 2010 together with Tim Knape is l'Artisan électronique, which is basically a 21st century version of the traditional potter studio. So it's an installation that was commissioned for Z33, art center in Hasselt. And when you entered the space, there was this installation on which you could throw virtual pots. So when you move your hand in front of the screen, you cross a laser beam, and this profile is being copied on the screen, and you can literally push your hand in the digital matter and start shaping it. This data was then sent to the ceramic 3D printer that we developed. For those who are still kind of, what is 3D printing exactly? 3D printing builds an object layer by layer out of a material. It's also called additive manufacturing because you add material exactly where it's needed. So this is extruding soft clay, and it's extruding it layer by layer, drawing the profile or the cross-section of the product on a downwards moving platform. We didn't design the final object. We only designed the framework in which people could go and co-design together with us. And we have a few 100,000 designs currently in our database. And these are just some examples. So we print them out, fire them in a kiln, and put them back in the gallery. And you can clearly see like a repeating aesthetic. It's not that people can go out and design a building in that piece of software. Everything becomes a vessel or a vase or an abstract thing. And they all carry our handwriting and the user's handwriting. This brings us to what I think is kind of the conclusion for this talk, is that we need to think about how we can create new industries, because the traditional industry of mass manufacturing and distributing through a retail channel isn't working anymore. And I hear that story over and over also from the traditional industry. Selling through shops is not working anymore. The most potential platforms are currently selling directly to consumers. So we have to completely rethink not only what can this machine do, but how can we redesign the way we interact with products. So I already I showed you this example of Nervous Systems. What's really clever about this system, so they have the online software. And if you're happy with it, you press buy. Again, it's sent to a 3D printing service studio that will print it out and ship it to the customer. But they've taken a lesson from the book of the internet. And on the internet, people have struggled really long with business models because data is so easy to distribute that it wants to be free. Data is too easy to copy. And therefore, one of the business models invented online is the freemium model. And that's basically, I think everybody is inside the freemium model today. It's Google, it's YouTube, it's everybody is doing the freemium model. It means that you give away 90% of your business in order to get 10% of people paying for it. Spotify, 90% of the people aren't paying for this. Gmail, 99% of the people aren't paying for this. Because it's so cheap data, it doesn't cost them much to give it for free, and they can earn everything back on the 1% of people that value an extra service. So what Nervous Systems did is, this is the paid version, but there's also a version for at-home 3D printing. It's a little bit simpler because a printer that you have at home is a little bit more restricted in its capabilities. But you can design a similar necklace and then print it out on your home printer for free. And this is also the ideal way to prevent, in my mind, to prevent copying. And I call it the no original strategy. Because in traditional manufacturing, we have an original that's being reproduced 1 million times. So the original is the target for the copy. If you copy that original, well, you have made an excellent copy. But in a model where there's no original, like here, every single one is produced for you differently than for you, there's no original to copy. If you want to copy this design, you have to copy the entire software, the entire infrastructure, the entire ID, and it becomes kind of a very complex and impossible task. So it removes the incentive to copy. One that we're working on ourselves is called stratigraphic manufacturing, and it's a distributed ceramics factory. So again, the idea of mass manufacturing in a central location is when we're actually going to pay for carbon and CO2 in the future, it will be impossible to sustain the current method of shipping products worldwide. So it will become too expensive to ship, to manufacture in one place and to ship it around the world. So we're looking at a system where we can distribute locally. So this is called distributed manufacturing. And what we did is when we developed the method for ceramic 3D printing, we immediately open sourced it. So everybody can replicate our machines and our methods and our clay recipes, etc. And so we have a community of a few dozen people now. There's about 500 people, but a few dozen that can really print in ceramics really well and that have all the skills and all the knowledge of ceramics. So we're joining them into a network, a digitally connected network, where people will buy one of our designs and it will be produced on the spot. This is not a new idea in 3D printing, it's kind of a standard idea, but the standard idea is that wherever you produce it, it should be identical. And I think that's a traditional second industrial revolution idea, that every copy of the originals should be identical. What we want to do is send these designs to these different manufacturers and allow them to print them and finish them in a way that that is bringing in their own influences and their own interests and their own locality in the production. So this guy is Jonathan Keep. He was the first who copied all our methods and started to use them in his own ceramics practice. So we sent these files to a dozen of these people, and this is his set in a traditional porcelain with a celadon glaze. If you look at these cups, they're entirely different, and these are produced in Taiwan. And they use different colored clays into the production process. This is a version of the bowl produced in Istanbul by Mustafa Kanyurt. You see much more earthen colors, a thick glaze applied to the inside. Also a little bit less refinement or exactness in the process. So he's allowing more errors in the process. And I think that's really important, that the digital isn't a very dogmatic and overarching ruling thing. The process and the clay should also tell their own story and take over from the digital. And that's a little bit the problem, and what we see is the future. That the Industrial Revolution brought a split of making and manufacturing. Like the craftsman would be making and manufacturing, but today everybody who calls themselves a maker is not really a manufacturer. The manufacturing happens in big plants somewhere else. And that is because with this industrial machinery, the means of production, those huge injection molding machines had become too elaborate, too extensive, and too centralized to be owned and operated by an independent craftsman or maker. But today we see that this is all moving back, and this is scaling back. Industry is scaling back to the size of the industry. And I want to conclude with this factory from Dirk van der Kooi. He's a Dutch designer, graduated like ourselves from Design Academy in Eindhoven. And what he did is he got himself a second-hand robot arm from a Chinese car manufacturing plant. And he repurposed it and he turned it into a 3D printer. And he embraced the aesthetics of 3D printing. Very thick layers so he can really quickly print a chair. And his upfront costs were kind of very minimal because he found a guy that just had to get rid of this robot arm. And he painted it, he refreshed it, he built his own extruder on it. And he started this small factory. And it's a very scalable system because he can produce 1 chair, you can produce 10 chairs, you can produce them according to demand. And what's also nice is that a digital product looks much more like software than like a physical product. I don't know how many of you are in software development? Nobody? 1, 2, few? Okay, so there's this, maybe you have to help me, it's release early, iterate often, something like that. So the idea with software is that it's full of bugs, but you push it in the marketplace anyway, because then actually you get reaction from people, you get feedback, it's basically market research that you're doing on the spot, and people send bug reports, they even might help you fix those bugs, and they improve your product. In traditional manufacturing, you had to do all of that research beforehand, and then push the product to the market in millions, and then probably it fails. So in his method, he's actually using the software idea. He made a crude design of his chair, pushed it out into the market, and now he's constantly iterating on it. So he produces 1 chair, and just like a craftsman would learn something from making 1 violin, and then improving and applying what he learned in the next violin, Dirk is doing exactly the same. So he prints a chair, sees how is it balanced, etc., and slightly iterates the chair. Each time it's slightly improved. And you don't really see it in the whole process. Most people think it's only 1 chair, and there's a rocking chair and there's a normal dining chair. But if you look at like his first chair and his last chair, there you see everything shifted, everything changed, every piece of the code, every line has changed. And this is my conclusion. With manufacturing going digital, we see a merging of aspects of pre-industrial craft economy, like locality and personal production, with high-tech industrial production tools, a combination that has the potential to shift power from industrial producers and those regulating infrastructure to the individual designer, maker, and consumer. In essence, every single one of you. I've taken my content from this book that we edited and published last year, which is called Printing Things, and explores this lowering of the barriers into manufacturing and what potential this has for the creative industry. So it features about 100 projects from artists, designers, architects, and we've written 8 essays from which you've seen the chapters I touched on, I think 3 or 4 in this lecture. I brought a few of them, so if you want to save on shipping costs and save my legs so I don't have to carry them back to Antwerp, you're welcome to buy one. Thank you.